Hello students. Today I would like to discuss about this Fourier transformation of sequence of impulses, or normally called as impulse train, that is practically seen in applications in engineering sciences. So this particular derivation is not available much on internet, like not much of the literature is available or YouTube videos are available. So people have to do this cumbersome work by themselves and there is not enough guidance on it. So I wanted to make a video particularly in this topic. Okay. So Fourier transform of sequence of impulses. We know that impulses functions are derived delta function, which are defined as delta of x, and of sequence of impulses we can define as f of t as summation of n goes from minus infinity to plus infinity derived delta function of t of minus infinity. This is defined at every particular value of n, which grows from minus infinity to plus infinity. Let us see graphically how it is. If we draw a graph, then we see that suppose I draw between f of t versus t, then this is suppose minus 3t, this is minus 2t, this is minus t, and this arrow represents this goes up to infinity, and at 0 also it goes to infinity, at 1t, at 2t, and at 3t, and it goes on when t goes between minus infinity to plus infinity. Okay, so this is a summation of Dirac delta functions which are defined at nt, that will be minus and plus. Now to find the Fourier transformation or break this function into the summation or finding the coefficient of the complex exponentials or cosines or sines, then we have to do the Fourier transformation. So those particular transformation can be done by simple means. I will tell that what are the ways to do it and how to obtain it very easily rather than trying it cumbersome. Okay, so first we will represent this function as a Fourier series. That is, the first step is finding this impulse train as a Fourier series of summation of complex exponentials. But f naught is fundamental frequency and f naught will be at different frequencies, and we'll see that what is the value of n, so that for that particular frequency what is the coefficient, and we'll see the frequency distribution. That is what is Fourier transformation. So now this particular, we will equate this function to this function, find the coefficient. Once we know the coefficient, we know the series. Once we know the series, we'll find the Fourier. Second step is to obtain Fourier transformation of the summation of complex exponential. Once we do this, then this transformation, that the function of frequency, is equal to the transform pair of this particular impulse train. Okay, so first of all let us follow the first step. Those who are familiar with Fourier series can easily write this about the coefficient. In case someone has no knowledge of it, he can look at this video. Those who have those, they can skip the video. Okay, so finding the coefficient for any function f of t which is a periodic function. Fourier series is applicable for periodic functions. Okay, so now let us say that a function f of t is periodic of time interval t. That means it goes from negative side to positive side of x-axis or time axis as minus t by 2 to plus t by 2. So suppose if we see as f of t, then we will see from minus t by 2 to plus t by 2. So in between this particular region, this is a one time period. So we'll define the coefficient. We will find out the coefficient. Now f of t, we are wanting to find it out as the summation of complex exponential okay. Now what I will do is I will integrate both sides from minus t by 2 to plus t by 2 and will multiply by 2 pi f naught and t dt. I'll do the same thing on this side also. Say these both terms get cancelled out because I 2 pi f naught 1t minus I 2 pi this cancels out. That is what my idea was, to take out this term out. So I got rid of these two terms. Now I'm left with dt. Now the value of n which lies between minus t by 2 and plus t by 2, because it is an integral value, so it could happen as minus 1, in which case it becomes minus t, and if it is plus 1 then it becomes plus t. But I'm integrating between minus t by 2 and plus t by 2. Like this is minus t, this is minus t by 2, this is plus t by 2, this is plus t. Though n values are standing here and here, but in between this there is only one value existing, that is 0t or 0 or n is equal to 0. So the summation simply does not mean that this is a constant, and the summation on n does not have a meaning, so it changes over to constant. I will put it out, minus t by 2 to plus t by 2 integral dt, that is, see, an integral dt is t from minus t by 2 to plus t by 2, that is cn into t by 2 minus of minus t by 2, that is cn into t. So finally the coefficient cn is 1 by t integral minus t by 2 to plus t by 2 f of t e power minus I 2 pi f naught and t dt. Okay, we represent various frequencies using n. So this is our formula we have defined for the coefficient of this exponential series. So now what we will do is we will find out for the given function. So our coefficient Cn is equal to 1 by t integral minus t by 2 to plus t by 2. Our function is this exponential, n is minus infinity to plus infinity. So we have seen that the coefficient is found out f of t is, we replace this as the impulse function, sequence of impulse function, and this is our term. Now if we see this function, we can change out these terms, that is, we can write this as 1 by t summation, I can take it out, n is minus infinity to plus infinity integral minus t by 2 to plus t by 2 t minus nt exponential of minus I 2 pi f naught nt dt. Now if I see this integral form, this is a property of the delta Dirac function, in which if I find out the value of n, that also comes to 0, because the only value of n that can lie between minus t by 2 and t by 2 is n is 0. So this becomes 0 and this becomes delta of t e power minus 2 pi f0 and t, where n is 0 again here also, so into 0, so this is 1. Integral delta Dirac function is basically property of it, which is 1. So 1 by t into integral of this whole term is 1, which you have seen in the last class video, that from minus infinity to plus infinity, if you see the integral, that it defines at only one particular value of n, that is t is equal to 0 when it is infinity, and the integral under the area under that particular Dirac function, if you see that limit when goes to, like t goes to infinity, or in that particular video we have seen in the previous video, if you can see in the description, then the area is 1. So the coefficient value becomes equal to 1 by t. So this particular sequence of impulses is defined as a summation of complex exponentials in which the coefficient of any particular waveform, if you see, that is constant. So all this summation of frequency series have one constant coefficient, that is 1 by t, 1 by the time period of it. Okay. So what we have obtained is this Cn is equal to 1 by t. So we can replace this as 1 by t for this particular function. So instead of writing this function, I can write this function when n goes from minus to plus infinity, and this is equal to the sequence of impulses. Now what I have to find is Fourier transform of it. So what I will do is, I will find the Fourier transform of this function, that is in the form of frequencies, is integral of minus infinity to plus infinity, summation of n is equal to minus infinity to plus infinity, 1 by t okay. So I can take the summation out. I can do integral and then summate, or I can summate the integral, the value is same. Okay. So I can take summation out and I integrate. Since capital T is the time period is a constant, I can take that one out also. So now this function I will write as e power minus I 2 pi t f minus f naught n dt, that goes from minus infinity to plus infinity. This is the definition of a Dirac delta function. E power minus 2 pi f t or e power 2 pi f t, this is the definition of Dirac delta function. So it will be in the form function of frequency. So this is summation of n is minus infinity to plus infinity 1 by t. It is a form of the function of this. So it is f minus f naught into n. You can, this is the answer of this particular question. We can rewrite this one also as, so it is a transform pair is this one. This is summation from n is equal to minus infinity to plus infinity 1 by t. Here is the function of f minus, some people write n by t because frequency is 1 by time period, or 1 by time period is frequency. So that is f naught 1 by t. So this is the answer that we have obtained in 2 simple steps. Thank you.